Hello everyone, welcome to my channel. So this is the part 12 on the chapter 1 sets, that is exercise 1.6, where we'll be discussing the solutions for the exercise 1.6. If you have any doubts on the formula, on the practical problems on union and intersection of set, please have a look on my part 11 where I have discussed about the theoretical explanation for the exercise 1.6, and on this exercise we will solve all the work problems on exercise 1.6. So let's directly start with our first problem. If x and y are two sets such that n of x is equal to 17 and n of y is equal to 23 and n of x union y is equal to 38, find n of x intersection y. So what was the formula for the practical problems on intersection and operation on sets? We have already solved it for when there are two sets and also for three sets. When there are two sets, we have formula what? N of a union b is equal to n of a plus n of b minus n of a intersection b. So n of x union y is what? N of x plus n of y minus n of x intersection y, right? So we can easily find from this n of x intersection y, because all other terms are already given. But y it is given here 38. Again, n of x is given as 47, and here it is given as 23. Now we have to find n of x intersection y, right? So I have written a small, this is a mistake, yeah, this is 17, right? So n of x intersection y is what? 40 minus 38, which is equal to 2. So n of x intersection y is here 2. I hope it's clear. It's very easy problem, right? You just have to put the formula and find the unknown from the formula. Okay, now let's discuss the second problem in it. If x and y are 2 such that x union y has 18 elements. So n of x union y is already given. That is what? 18 elements. Then n of x has 8 elements. So n of x is equal to 8 and y has 15 elements. So n of y is equal to 15. How many elements does n of x intersection have? X intersection y have? That is n of x intersection y is what we have to find from the formula. What is the formula? N of x union y is equal to n of x plus n of y minus n of x intersection y. That is 18 is equal to 8 plus 15 minus n of x intersection y. Okay, what is n of x intersection y? 23 minus 18, that is 5. So n of x intersection y is 5. I hope it's clear. It's very easy. You just have to put the formula and find the unknown from the formula. Now let's discuss the third problem again similarly. If a group of 400 people, 250 can speak Hindi and 200 can speak English. How many can speak both Hindi and English? That is, we have to find the people who are common. Let's say the number of people who can speak both the languages. So there are 400 people. That is, the union is already given. N of H union he, H union E, where H is the Hindi number of people who can speak Hindi and E is the number of people who can speak English. That is given in the question as 400, right? And number of people who can speak Hindi, that is 250. That is also given in the question. Number of people who can speak English, that is also given in the question, 200. You just have to find n of H intersection E, that is people who can speak both Hindi and English. Just substitute in the formula, that is 400 is equal to 200 plus 250, that is 450 minus n of H intersection E, that is n of H intersection E is equal to 50. 50 people can speak both Hindi and English. 50 people can speak both Hindi and English. So that's all for the question number 3. Now let's find the question number 4. If S and T are two sets such that S has 21 elements, T has 32 elements, and S intersection T has 11 elements. How many elements does S union T have? So N of S union T is equal to n of S plus n of T minus n of s intersection t. So s is already given in the problem, that is 21. Again, t is also given, that is 32, and s intersection t, that is also given, right? So just we have to substitute all these values and find our final answer. That is what, 21 plus 32, that is 53. 53 minus 11, that is 42. So S union T is 42 in the problem. So that's all for the problem number 4. And now let's go to the fifth problem. If X and Y are two sets such that X has 40 elements, X union Y has 60 elements, and X intersection Y has 10 elements, how many elements does Y have? So we have all the constraints and we have only one unknown again in the problem. So if n of X union Y is equal to n of X plus n of Y minus n of X intersection Y. So if X has 40 elements, this is given, and X union Y has 60 elements, that is also given. We have to find n of Y only. Again, X intersection Y has 10 elements, so that is also given. 40 minus 10, 30. 30 plus n of Y, 60 is equal to 30 plus n of Y, right? So n of Y is equal to what? Y has 30 elements, that is n of Y is equal to 30. So that's all for the fifth problem. And now let's do our sixth problem. In a group of 70 people, 37 like coffee, 52 like tea, and each person like at least one of the two drinks. How many people like both both coffee and tea? That is, we have to find the intersection of that. Let's say C be the number of elements who like coffee, and T be the number of people who like tea. So what's the formula? N of C union T is equal to n of C plus n of T minus n of C intersection T, right? N of C union T is already given in the problem, that is 70. Again, n of C coffee, people who like coffee, that is also given in the problem, that is 37. And number of people who like tea, that is also given in the problem, that is 52. Now we have to find n of C intersection T from the formula. So n of C intersection T is equal to 89 minus 17, that is 19. 19 people like both tea and coffee. So that's all for the problem number 6. And now let's do our seventh problem. In a group of 65 people, 40 like cricket, 10 like both cricket and tennis. How many like tennis only and not cricket? So let's denote the C as the number of people who like cricket and T as the number of people who like tennis. So n of C union T is given from the question. What it is? 65. N of C, that is people who like cricket, that is also given, that is 40. N of C intersection T, that is people who like both cricket and tennis, also given, that is 10. Now by using the formula, you can easily find n of T, right? What is n of T? To find that, use the formula n of C union T is equal to n of C plus n of T minus n of C intersection T. So C union T is 65, n of C is 40. This you don't know, you have to find n of T from it, minus n of C intersection T, that is 10 people like both cricket and tennis. So n of T is 35. So 35 people like tennis. So that was what asked in the question. Now let's find our final problem. Okay, but the question is not over. It is asked that how many people like tennis only and not cricket. So we have found only people who like cricket. So we have to find people who don't like, that is we have to find n of C minus T. People who like tennis only and not cricket, that is n of C minus T is what? N of C. If you subtract from n of C minus n of C intersection T, you will get the number of people who like tennis only and not cricket. So I wrote it in a wrong way. N of T minus C, that is n of T minus n of c intersection t. If you subtract from the number of people who like tennis, the number of people who like both tennis and cricket, you will get the number of people who like tennis and not cricket. That is 35 minus n of c intersection t is 10. 10 people like both cricket and tennis. So 35 minus 10, 25. 25 is the number of people like only tennis. And what is the first answer? 35. 35 is the people who like tennis. And in this, there are also people who like both tennis and cricket also. And the second value is the people who only like tennis. I hope it's clear. It's very easy. Now let's do our last and the final problem. That is the eighth problem. So the eighth problem is, in a committee, 50 people speak French, 20 people speak Spanish, and 10 people speak Spanish and French. How many people speak at least one of the two languages? That is, we have to find the union of it. So for that, let's take the French as F, as usual, yeah, S as Spanish. N of F is already given in the question, that is 50. Again, N of S, people who speak Spanish, 20. Number of people who can speak both Spanish and French, that is 10. That is also given in the question. Now we have to find the union. S union F is equal to N of S plus N of F minus N of S intersection F. That is 20 plus 50 minus 10, that is 60. There are 60 people in the committee who can speak at least one of the two languages. I hope it's very much clear. With this, we come to an end on the exercise problems from 1.1 to exercise 1.6, and on my next video, we'll cover up on the work problems on miscellaneous exercise. So let's see you over there. Bye bye.